Okay, let's go over this. So if we have this is our x value and this is our y, and we plug it into our 6 formulas here, you should get that the sine of your angle is the y value, -8/17. The cosecant of your angle is just the reciprocal of that. It's 1/y, so be -17/8. Because remember, you don't have to write this down, but when you do 1 divided by a fraction, it's the same as flipping that fraction and multiplying. If you multiply by the denominator, 17/8. So we got right there. For cosine, the cosine of that angle is just the x value, -15/17. And then the secant would just be the reciprocal of that. So -17/15. The tangent does require you to do at least does one more step. But if you have y/x, so I'm going to do -8/17 divided by -15/17. I don't like having these fractions within fractions in my answer. So to fix that, I multiply by the denominator of one of the fractions. So I'm going to multiply by 17. But actually, since they both have the same denominator, it'll cancel on the top and on the bottom, leaving you with just +8/15. Again, because two negatives here would make a positive. And then the cotangent of that is just the reciprocal. So instead of 8/15, it's 15/8. All right, questions on the bell work. Do all 6 of these answers look all right? Or does anyone need more time to write? That one. Evaluate the 6 trig functions. So let's talk about how you would do a problem like this. So every once in a while, they'll give you an angle that is not between 0 to 2 pi. Like this is a -pi/3. That would be a problem, except we know how to find coterminal angles. So for this problem, I'm going to find its coterminal angle first by adding 2 pi to it. That way I can find the positive angle that stops at the exact same point, but that's within 0 to 2 pi. All right, if I want to add 2 pi to this, I'll need a common denominator. So if I multiply by 3, multiply by 3, I get -pi/3 plus 6 pi/3. And 6 pi/3 minus 1 pi/3 is 5 pi/3. So this is really the angle we're talking about. These are the same. These angles will start and stop at the same position. But if you look at your unit circle, this angle right here, they label it as 5 pi/3, not -pi/3. So if you look at your unit circle, you should find that the coordinates of that point right there are a half (-√3/2). All right, so remember there are 2 steps to solve all of these problems. First is to find your angle on the unit circle. And that should give you your x, y values. For our problem, that's a half negative square root of 3 over 2. Okay, any questions about the first step, how I got these numbers, a half and negative square root of 3 over 2? All right, that's step 2. We're going to use our formulas to find the 6 trig functions. So the sine of your angle is supposed to give you your y value. So its answer would be negative square root of 3 over 2. The cosecant of your angle is just the reciprocal of that, so it'll be negative 2 over the square root of 3. WebAssign will accept this as an answer, but you should be ready to rationalize it because the ACT and your future math classes probably won't. They don't like having this radical in the denominator. So to fix that is actually fairly easy. We just multiply by the denominator to the top and bottom to get us negative 2 square roots of 3 over the square root of 9. But the square root of 9 is just 3. The cotangent, or sorry, not cotangent, cosine, getting ahead of myself, of your angle is just the x value. So it'll be a half. Secant is the reciprocal of sine. So instead of 1 over 2, it's 2 over 1. The tangent of the angle is supposed to be y over x. So it'll be negative square roots of 3 over 2 over a half. But again, we don't like fractions within fractions, so multiply by 2. And again, it's going to cancel out at the top and the bottom to give you just negative square root of 3 over 1, which is the negative square root of 3. Cotangent is the reciprocal of tangent, so it'll be negative 1 over the square root of 3. And again, WebAssign will accept that as an answer, but we can rationalize it very quickly by multiplying by the square root of 3 to get a final answer of negative square root of 3 over just 3. And just like that, your Monday was made richer for being in a trigonometry class. Because, I mean, can you just look at what's on your screen right now? This is a work of art. This could be up in a museum. I mean, just look how beautiful it is. Okay, the circle is a little offset to the right. Sure. Okay. Sure, this part, this handwriting right here isn't the greatest. But sometimes, the best things are great because of their imperfections, right? Right? That's right. All right, questions on this problem? Or does anyone need more time to write this majesty onto a sheet of loose leaf paper? Okay. Well then, your turn. So again, you have 2 steps to solve these problems. Find these angles on your unit circle, and then use your formulas to get the 6 trig functions for each. Both of these angles are between 0 to 2 pi, so you won't have to worry about adding or subtracting 2 pi to find a coterminal angle. You should just be able to read them from the chart. I'll give you 3 minutes to try that, and then we'll go over it. Okay, so let's go over this. Hopefully for 5 pi over 4, you found that the units on the unit circle that's this angle right here, which corresponds to the point negative square root of 2 over 2, negative square root of 2 over 2. So the sine of your angle is just the y value, negative square root of 2 over 2. the cosecant of your angle is the reciprocal of that, negative 2 over the square root of 2. But again, we should try to rationalize that. And this is one where I say, I don't even know if WebAssign would accept this one, because it does turn out that this simplifies pretty neatly to becoming negative 2 square roots of 2 over the square root of 4, which is just 2. But then you have a 2 in the numerator and the denominator, so they end up canceling out, and you getting just negative square root of 2. And so since the answer is just negative square root of 2, or just the negative square root of 2, even though that's technically the same thing, I think that I don't know, I guess you'll see. If you type that in and it says wrong, then rationalize, and you should get it right. The nice thing about this problem is, since the x and y values are the same, the cosine of your angle is the x value, but that's the same thing. And so then the reciprocal of that would be the same thing too. Negative square root of 2. The tangent is also pretty easy to find. Since the y and x values are the same, anything divided by itself is just 1. And the reciprocal of 1 is 1. Isn't that neat? No. Okay. All right, for the second one, you should have gotten that pi, that angle, is actually along the negative x-axis. That's this angle right here. So the point it corresponds with is negative 1, 0. And so the sine of pi is the y value, so it's 0. The cosecant of pi would be 1 over 0, but you can't divide by 0, so this is undefined. Pi is not in the domain of cosecant. If you try to plug in pi, it'll tell you that the answer is error, division by 0. So it's undefined at pi. It has a vertical asymptote at pi. Cosine is your x value, so it's negative 1. Secant is the reciprocal of that, so it is also negative 1. Tangent is y over x, so it'll be 0 over negative 1, which is 0. Cotangent is the reciprocal of that, so it's 1 over 0, so it is also undefined at pi. So last thing we're going to talk about is just some notes that really, again, we'll have some application to the homework, but mostly it'll have application in future of chapter 4. So we're going to start talking about the properties of each 6 trig functions, and we're going to start our discussion with sine and cosine. The domain of sine and cosine is all real numbers. In that last example, cosecant and cotangent were undefined at pi, there is never an angle that'll make sine and cosine undefined. Because according to their formulas, they're just y and x, so they don't have division in them. So you never have to worry about dividing by 0. So the domain of sine and cosine is everything from negative infinity to infinity. There's no angle you can't take the sine or cosine of. Their range is -1 to 1, which should make sense. If you look at the unit circle, the sine of an angle gives you the y value, and the largest y value you could ever get is 1. The lowest y value you could ever get is -1. The cosine of an angle gives you the x value, and again, the lowest x value you could get is -1, and the largest x value you could ever get is +1. So that's why their range is between -1 to 1. Also, if you think back to geometry, that should make sense, because if the sine is opposite over hypotenuse, since the hypotenuse is always the longest side of a right triangle, it is impossible for the opposite to be bigger than it, which is why it's impossible to get answers bigger than 1. At best, they could equal. Most of the time, the opposite is smaller, and that's how you get numbers between -1 and 1. But you'll never get numbers where the opposite is bigger, so you never get higher than 1 as an answer. Same thing goes for cosine, right? It's just the adjacent instead. All right, we got one more slide after this. Last property on this slide is about even and odd. So if you remember back at the start of class in like August, a function is even if it's symmetric about the y-axis, and a function is odd if it's symmetric about the origin. But generally, the reason why this works is because the cosine of a negative angle is the same as the cosine of a positive angle. In other words, if you think like I'm trying to take the angle of positive pi over 3 and negative pi over 3, those angles have the same x value, right? The x value for both of them was +1/2. Since secant is just the reciprocal of cosine, it's the same thing. It would just be 2/1 and 2/1. So positive angles and negative angles give the same x value. Sine, cosecant, tangent, and cotangent are odd because when you change signs, when you go to negative angles, you get the opposite answer. So again, back to that Bellwork one we did, or that example we did, this y value is square root of 3/2, and its negative angle is negative square root of 3/2. So you get the same answer, it's just the opposite sign. And again, that happens to be the same thing with cosecant, tangent, and cotangent. All that happens when you change the angle from positive to negative is you get the same answer, just with the opposite sign. So cosine and secant are symmetric about the x-axis, which when we graph them later in chapter 4, you'll see that another way. Sine, cosecant, tangent, and cotangent are symmetric about the origin. In other words, they have rotational symmetry. And again, when we graph those later in chapter 4, you'll see that in their graphs, they do have that rotational symmetry. All right. Questions about these three properties, or does anybody need more time to write? Hi, Sunny Bunny. Is it cold outside, Sunny Bunny? He's got a sweater on right now because he's a short hair doggy. Breezy, my border collie, she'll just go out in the snow and roll around in it. Doesn't bother her at all. But Sunny Bunny, he doesn't like being cold. Okay, nobody stopped me, so I'm going to clear this. Last property. All right, last property has to do with periodic functions. This definition isn't super critical for you to have down. I mean, I guess it would be nice. This is really important, though. So a function is periodic if there's a real number you can add to it, to an input, and get the same answer as a previous input for all values in the domain. Sine and cosine are periodic, and their C value, their period, is 2 pi. Which again should hopefully make sense to you, because if you think about the unit circle, every 2 pi radians you go around is a full revolution. So the answers between 0 to 2 pi will be the exact same answers as the answers from 2 pi to 4 pi. Same as 4 pi to 6 pi, 6 pi to 8 pi. Every time you go 2 pi around the circle, you've made it back to the beginning and you start repeating your answers again. So this answer right here, pi over 2, has the same answer as 2 or 5 pi over 2. I think that's 2. Yeah, maybe I'll use decimals for this. This answer of 0.5 pi, I think that'll show it clearer, has the same sign value as 2.5 pi, which is the same sign value as 4.5 pi. Every time I've added 2 pi, I end up right back at this same spot, which means I have the exact same y value every single time. Does that make sense? Is there any questions about that? Okay. So once you have those 4 properties down, you can use them to help solve problems. So for example, 13 pi over 6 is not on the unit circle. But we know sine has a period of 2 pi. So if I take 13 pi over 6 and I subtract 2 pi from it, its coterminal angle will still have the same answer, just like we did in an example earlier in this class. Get a common denominator. Gives us pi over 6. So the sine of 13 pi over 6 is the same as the sine of pi over 6, which according to our unit circle has a y value of 1/2. For cosine, this negative angle, remember that cosine is even. So the cosine of negative 7 pi over 2 is the same as the positive angle of 7 pi over 2. And again, if we subtract 2 pi from that to get a coterminal angle, 7 pi over 2 minus 4 pi over 2 gives us 3 pi over 2. So the cosine of negative 7 pi over 2 is the same as the cosine of 3 pi over 2, which again is an angle we can find on the unit circle. The x value of that angle is 0. And you can double check these these answers with your calculator. Just make sure it's in radian mode. Hit mode and change the degree to radians. But then you can type these in and see if they really are the same and you got the right answer. All right, it's 10:05. That's the last thing we're doing today. Any questions about this? Okay, well, once you have this written down, you can head off to 7th hour. Have a good rest of your day, everybody. And if you run into any problems with the homework, just let me know.
Have a good rest of your day.
You